Hi everyone. Today I'd like to introduce you the KMX 100G UDP IP core and the KMX 100G Make PCs code by a reference design demonstration, which are based on these two cores. The demonstration will show you some basic features and architecture of these two cores and how to use them, how to integrate them into your design and the system. The whole demonstration will consist of 5 parts. We start with the first part, the architecture of this course. First of all, let me briefly describe the KMX 100G UDP IP core. The core implements UDP IP protocol stack in hardware to achieve line speed and deterministic traffic behavior in real time, which are critically important for some applications. The core will handle both the traffic and fill out malicious incoming packets. The core supports UDP IP TCP, ICMP, ARP, DHCP, IGMP, as well as unicast, multicast, broadcast. The KMX 100G Make PCs core contains Make module and PCs module. They are fully compliant with IEEE 802.3BA. The Make module supports 32-bit CRC and the port frame for flow control. The PCs module supports ISFEC, which are defined in IEEE 802.3BJ Clause 91. From Make module to PC module is the interface CGMII. The core implements CGMII loopback and the 100G transceiver interface loopback for testing, verification, debug purpose. Also, the core implements error injection for ISFEC verification and testing. Now let's focus on demonstration platform. Take a look at the picture on the whiteboard. The platform contains 3 components: FPGA board, KCU116, 100 Ethernet card, and a PC. In this demonstration, FPGA board with FPGA device on it, supporting 100 networking. The board acting as an Ethernet entity. The 100 Ethernet card were using Manlock's Ethernet adapter card, which are installed on the PCI bus inside the PC. The PC together with the 100 Ethernet card will acting as a network in this demonstration. So the Ethernet entity connected to the network through 100G cable. For the demonstration, there are 4 software applications are used, which are running on PC. Vivado is responsible for configure the FPGA device with 1 serial connection. Wireshark captures packets to the Ethernet card from the Ethernet card. Serial terminal using another serial connection to control, configure, and monitor the FPGA device with a reference design running on it. Also, TNATO is responsible for generating required packets, will be used in the later on demonstration. The reference design architecture. Let's take a look at the picture. The reference design architecture contains 5 components. Top layer is responsible for generating clock and manage the clock system for the whole forward reference design use. It also acts as a user logic to connect with KMX 100 UDP IP core to send to receive packets. The connection is SS4 stream bus. The next module is status control register. Through a set of control registers. This module have two connections with the IP cores. They both are SS4 light bus. They control, configure, and monitor these two IP cores. From KMX 100 UDP IP core to 100 Mac PC's core, the connection is SS4 stream bus. Now, let's take a look at the real stuff of demonstration platform. This one is the FPGA board KCU16 from Xilinx. On this board, we have a FPGA device in here. And we have two serial connections, which are used by both Vivado and serial terminal. This is the 100G cable. They have 4 lines. Each line supports 25 gigabit per second. And this 100G cable is connected to here. This one is connected to the Ethernet card, which is already installed inside the PC. And these two connections is connected here to PC. Now we started the demonstration. First thing is to power on the FPGA board. These 8 ladders are useless. The reference design uses them to indicate its configuration and the initialization process status. When all the 20 PCs virtual channel reaches their block lock and mount lock, these ladders go on. Right now, there's nothing inside the FPGA device running, so these ladders are supposed to be off. There are 4 windows, small windows on the screen. The network connection window lists all the connections. Connection Ethernet 3 with device name Manlox Connect X5 adapter, which connects to FPGA board. We pay attention to this connection status change. Right now, its status is network cable unplugged, which means the connection is non-active. The Wireshark board window lists connections. Ethernet 3 connection is on the list. We go to this connections display window. The packets from FPGA device and sent to the FPGA device are displayed in this area. Serial terminal window has 3 text fields and 1 text area. These 3 text fields are used to send the KMX command to FPGA device. The message returned from the FPGA device is displayed in this text area. The command window. In this demonstration, we use the command window to do 2 things: configure Manlock card and pin the FPGA device IP address. The Manlock card and the FPGA device with reference design both have 2 modes, ISFEC mode and no ISFEC mode. For Manlock card to switch between these 2 modes, we use Manlock provider command. To configure the FPGA device, we use serial terminal text field to send KMX command. By default, the FPGA device with reference design, the default mode is no ISFEC. So we need to configure the Manlock card to no ISFEC mode. This is the Manlock command. Now the Manlock card with mode no ISFEC. Let's load the reference design into the FPGA device through the Vivado platform. Right after the loading is done, the top-level module started to configure the reference design with MAC address and IP address. The message returned from the FPGA device about the configuration is displayed in this text area. The message shows that the reference design MAC address is 30789801 FA4E, and the IP address is 60888006, which is 192.168.173.6. Now let's take a look at the network connection window. The connection Ethernet 3, its status changes to network from the previous network cable unplugged. Let's go to its status window. The status window shows that its speed is 100 Gbps. The Malloc card IP address is 192.168.173.3. On the command window, we already know that the FPGA device IP address, we pinned the IP address 192.168.173.6. There is a bug returned, so this connection is on. Let's take a look at the Wireshark window. The activity is going on. Let's look at this pin. We just do the pin related activity. 192.168.173.3 and send ICMP pin request message to 192.168.173.6, which is FPGA device IP address. And the FPGA device IP address send back the pin reply to 192.168.173.3, which is Malloc card IP address. Now we are using the KMX ARP request IP address register. This register is used to ask FPGA device to send out IP ARP request message to specific IP address. The register address is 0010. The text field 3 is listed the IP address, this command. We click here to send out this command. And then we look at looking for the expected packets from the Wireshark window. The 30789801FA4E broadcast ARP request message for 192.168.173.3, and the Malloc card send back the ARP response message to the FPGA device. We just send a command to FPGA device, and the return message from the FPGA device is displayed here. The return message has two parts. The first part is the echo of the message command we send out. The second is this one is 0000020018. 0018 is ISP register address. 002 is this value of the register. It indicates a scope of events. 02, the events is represented events ARP reply message is received. Now we demonstrate the ISFEC mode. First of all, we need to use the malloc provider command to configure the malloc card to ISFEC mode. Now the malloc card in the mode of ISFEC. Let's look at the change on the network connection window, Wireshark window, and the 8 user layers. The Ethernet 3 connection status has changed to network cable unplugged. The package window of connection Ethernet 3 stops. And the 8 user legs on the FPGA board these 8 user legs go off. The reason of this is right now the malloc card is in the mode of ISFEC, and the FPGA device reference design, the mode is no ISFEC. The data stream of the two modes are totally different in format. So this is why. So we will use KMX command to enable ISFEC in the reference design on the FPGA device. The command is in the text field too. Okay. Now we send it out the command. Now let's take a look at the network connection window, the change. The connection Ethernet 3 return back to the network connection status. Let's take a look at status window. The speed is 100 Gbps. Is on, the connection is on. And let's look at the Ethernet 3 connection package window on the Wireshark. We saw that the traffic is returned back to normal. Let's take a look at the 8 user layers status change. This 8 user layers here are going on. So right now the malloc card mode and the FPGA device with reference design mode are both ISFEC. Now we like the previous test, we tested the KMX ARP request IP address register command to see whether or not we got the expected package. Okay, the message is, the package is here. The FPGA device send out the ARP request for 192.168.73.3 to the malloc card IP address, and the malloc card is send back the ARP response message to tell its MAC address to the FPGA device reference design. Now the demonstration first part is finished.